Hello everyone, I am Manav and in this video we are going to be learn about the different types of compound. Yes, different types of compound like acid and bases. Okay, and we also take a closer look on the different types of indicators. Indicators like that tell us which thing is solid, not solid, acid or a base. Okay, we can make them through the nature, through these leaves. Okay, and through other organic substances, and we can also make them through our laboratories or lab in our lab through some chemical experiments. Okay, and we also we also look about the different types of acids. Okay, citric acid, uric acid, okay, etc. So let's begin. Acids. So let's begin with acids. Acids are like we get scared that they are chemical. Okay, so we also said that they are chemicals. Okay, so let's write acid. Okay, and just mainly most of the chemicals, if we do like this, we pour on it. So what will happen? They get burned. It's also we say it's an acid, but we're scared from the acid one that it is a scared. It's a chemical. Okay, it is harmful for us. Okay, so we say that the acids are harmful for us, and acids acids come from acidious word. From acidious word. What do you mean by acidious word? What is the meaning that? It's mean we say that sour. What is the meaning of sour? Meaning sour in taste. Okay, I don't like sour and taste like this lemon. Okay, a lemon juice. I don't like this. So it's mean that I not like citric acid because it's a type of acid. Okay, so we say that it is soaring. Okay, they are mainly sour in taste. Acid are mainly sour in taste. Okay, and acid are like malic acid and archetic acid and citric acid. Okay, there are many types of acid, and one is formed through the urine. Okay, a urine mean it's when the washroom, when we go to the washroom, that is urine. Okay, there is another acid, and in when we eat more over exclusive, we eat more oily foods. Okay, so we say that there is a burning in our stomach. What is that? This is also the acid. Okay, there's a type of acid that is on our stomach. Okay, and they get in our stomach, so we get like nothing, anything is burning in it. Okay, and then we eat some bases. Okay, and then we feel that we are fine now. Okay, so this also thing happened with me also. Okay, so acid we say sour in taste, but not do that always taste it and say it is sour. So it is acid. Okay, there are many indicators to indicate that it's an acid or a base. Okay, so don't taste this acid. Okay, you can taste like this lemon is an acid. Okay, it is a citric acid. It is sour in taste. Okay, we know, but the organic substances we can taste, but the chemicals are not because they are harmful for us. So, okay. And after that, the acids, after that, there's a bases. What do you mean by bases? Bases are come like bitter in taste. What does this bitter mean? Bitter in taste, okay? Like Loki, bitter in taste. Okay, the bases are mainly they are bitter in taste. For example, let's make a beaker. It's we say a lemon juice. And at the same time, we having the soap water. Okay, the solution. We said solution. We have mixed up the soap. What we do? If I having a bucket or this like this beaker, so first I pour some water, and after that and I do like this with the soap, and I pour some soap. Okay, so that is this is our soap water. So we say that the soap water is this. Yes, because it is bitter in taste. But don't taste these soap water because it is harmful for us. There are many harmful toxics. Okay, in this soap water, so don't taste it. Okay, and this lemon water, we know that is sour in taste. We can drink it. We can taste it. It's mean it is an acid. So we said that the acids are bitter in taste. Okay. Bases are in our daily life. Okay, we use bases like toothpaste. Toothpaste is also our basis, and a soap is base. Okay, and that I have told you about a thing that we get acidity in our stomach. Okay, so when we are feeling not well, so we drink even okay, it's a type of acid. Okay, it's a type of acid. Okay, we say that when the acid come in the contact of the bases, so the acid gone neutral, and the bases work, and we feel fine. Okay, so bases okay, the bases are fully different from the acids, and they are bitter in taste. And we are using these bases everywhere. So, in the early time, people was taste that and then tell it's a base or a acid. Okay, so if they get a taste of so they say it's an acid. But when they get bitter, okay, then when they get bitter, so it means it is the base. Simple. Okay. But after the scientists told them that don't drink these, if they eat if they drink or they try to taste an toxic thing to find out that it's a base or acid, so they will know it well and they can't say that it's a base or a acid. Okay. So after that, after some researches, these scientists find some indicator of turmeric and other like laboratory lab the indicator that are made in the laboratories in the labs through the chemicals. Okay, and some are the natural indicators. And the scientists also tell that if I having any acid if I having any acid and if I mix it with the water, yes, I tell you that the acid you don't mix with the water. Okay, there's explosion also. Okay, so when they will say that when the acids are in the water, so what they release, there are some bubbles, like these bubbles. These bubbles are in this bucket we say with the water when the acid are there, and it releases H plus gas, mean hydrogen plus. Hydrogen plus. Why this plus is here? Why not only H? So I tell you that's why this happening. So our hydrogen only have one electron and one proton. So like this, we made this with this is plus and this is electron minus. So any material or any other substance come here and slap to the hydrogen and take this electron. So now it's having zero. It's having zero electrons. Okay, it's only having a one proton. So when another substance comes, but he can't enter air and store the proton of the hydrogen. Okay, so when it comes, this is a fact that any atom we can't, any substance can't store its proton. Okay, because these orbits or orbitals we say are too strong. Okay, we say they are the walls of the proton and neutron. Okay, so our hydrogen atom only have now, once again, only have now a proton. Okay, it's only having a proton. So we use the sign H plus. Okay, H plus. We can't say that H minus, because the proton can't be solved by any substance, any other substance. So it is known as, we say, H plus. How we found out? We found out that any substance, for example, we made this bucket of this beaker like this. Okay, this beaker, and our acid is in it. So how to find that a bucket, any acid that is mixed up with the water, it is releasing hydrogen plus? How to find out that? It's easy. Take the matchstick and glow it and keep it like near. So when you keep it like near, if it is an acid, so and the H plus is releasing, hydrogen plus is releasing. So there will be like this, like this, a small flame. Okay, so we say it is releasing H plus. And after that, they also made some indicators. Let's make an indicator of turmeric. So I tell you that if turmeric indicator, if it is our acid, so it is in yellow color. Now let's make a turmeric indicator. So see, having turmeric. Let's mix it up. Now our this indicator is ready. Alright. See, our indicator is ready. Now, if its color is still now after mixing some another substance, so it means it's our acid, but it's changed into the brown color, so it means it's our base. So this is we know that our lemon is an acid. So let's mix it up. See, the drops are going. So now mix up. Now see, the color is too lighter than before. Before mixing this lemon drop. So see, it is still yellow. But if I mix detergent to it, so see now. Wait a second. Now see, it is red brown. Okay, it's red brown. So it means our detergent is our base and our lemon is our acid. Okay. So let's, oh wait a second, and if I then again mix it again, so what will happen? It's still like brown, brown. Let's see. See, it's now yellow. Alright, it's a magic, but it's not a magic, it's a science. So let's wait a second. So now we have understand that a turmeric indicator, when it's changed into the red brown, so it means we have mixed our base, okay, any base. But if we mix up the acid, so it is still yellow like the color of the turmeric, but it is too light than the before adding any acid. So after that, there is another our natural indicator. What is that? That is our red cabbage leaves. Red cabbage. leaves. Okay. So take the red cabbage leaves, and if they will stay in the red color after mixing something. We say after mixing, we say lemon. If it's still red, so mean it's acid, but if it changes into the blue color, okay, blue, so it means it's our base, okay. And there are two types of laboratory, or we say lab man-made indicators that are not natural. The red cabbage is natural because it is we grow that from the agriculture, through the agriculture processes, and our turmeric we also get through the agriculture processes. So we say it's natural, but in our chemical. So there's Fallophaeus. There's a Fallophaeus indicator. It is like water. Okay, it's like water. Like water in the first case. Okay, like this. It's a water. Simple. That it is transparent. There is no color. Okay, in after mixing any acid to it, it is still in the transparent form. But if we mix the uh, our base, so what will happen? It changes its color. Yes, it changes. For example, like this. Like this. So when we mix up it with any base, for example with a soap, because a soap is a base, or with a toothpaste, so what will happen when it's mixed up? It changes into the potassium permanganate color, mean the very dark volatile color. Okay, so it means it's a base. And now we have studied that we can find the base and acid through indicators by changing its color. Okay. Now we find that how to change the smell. There's a change in the smell of any substance. So it tells us that it is a base or a acid. So for example, we have onion. Alright, this is our onion. Like this. This is our onion, and I have cut it in a slice. Like this. So when I smell it, it is its own smell. And when I drop some drops of the acid, so what will happen? Its smell is same. Okay, but if I mix our a base, so what will happen if I mix a detergent, or soap, a toothpaste, or okay, so what will happen? There will be no smell. Yes, neutral. We say neutral smell. Okay, if we mix up this base in it. And after that, there are many types of acid. So let's begin. Our lemon. What is the name of the acid that is in the lemon? Its name is citric acid. Yes, it is sour in taste. Okay, and apples and other are not. Our vinegar, we have vinegar. So it having Arctic acid. Okay, and our golgappa. Okay, the water of the golgappa. it is of tartaric acid. We say it's tartaric acid. Okay, so we see that if I having a bowl of golgappa, okay, of golgappa water like this, so we see that there are some yellow like this here, like this color is here. Okay, like this. So what is that? It's also a acid, and this is known as tartaric acid. And many people say that the tomato has citric acid, but it is wrong. Our tomato has tartaric acid. Yes, tartaric acid. Okay, and urine have urinic acid. Okay. And the scientists also tell us that a base, when we find that there is a base, it's a base, any object and substance is a base. To find out that, there is another method. Okay, so that is we having a beaker, and if we having some base or any acid, and mix up with water. Okay. So after that, it will release OH2. Yes, oxygen, hydrogen, yes. It will release this gas. Like this. Okay. And after that, oh. Let's understand some reaction, some chemical reaction of the acid with the metals. Okay. So if we're having zinc is a metal. We know that. And if we add with any base, okay, now acid, citric acid. Oh, wait a second. Let's take the example of our hydrogen. Okay. So hydrogen. Every metal or any substance take the hydrogen electron. So if any substance, we say oxygen, O2. Oxygen say to hydrogen to give me your electrons and make you your form H plus. So zinc say, hey oxygen, left in this hydrogen and take me. I will give you unlimited. I will give you 810 electrons freely. Okay. So he say okay. So he say to hydrogen to go here. So hydrogen is waiting for another hydrogen. So then after some kidnapping, another hydrogen comes. So they say that this oxygen, zinc are too bad. So we fly in the air. Okay. So it is not too bad. Okay. So when they plus, what we get are hydrogen gas. Mean hydrogen H2. We get H2 gas. Okay, so when we mix our acid with an zinc, I'm not saying zinc, metal, so we get a salt and also our hydrogen gas. So we understand that's how we get this hydrogen gas. And you know, some metals are less reactive. Okay, so for example, if we have silver and with hydrogen and again oxygen. So here oxygen has kidnapped the hydrogen. Okay, so silver come. And silver said to oxygen to left him, I will give you my my electron. So oxygen sent. There is no interest with your deal because you are non-reactive metal, okay? And so there is no interest. So he takes the electron from the hydrogen, and hydrogen become H plus. Okay. So this are gold and silver. They are we not say that they are fully non-reactive neutral, but their capacity is low of the reaction with other metal. So to exchange to donate the electrons of the electrons. Okay. And so we also use this silver and gold in our jewelry. Why we use? Because they not lose their properties. Okay. If we having a silver jewelry after 20, 30, 20, 25 years, it is after some time it gets only some black. Okay. After a long period of time. Okay, so we said that this is the reason why we use silver and gold in the jewelry. And after that, our acid rain. We also get acid rain. What is the meaning of acid rain? We say the rain of the acid. Okay, so the acid rain have yellow color, some yellowish color. It is also harmful for us. So let's understand how the acid rain falls on the earth's surface. So there are some buildings, some factories. Wait a second. We say this corner of this board is a factory. It's a part of our factory. So there are some like these things that release the fossil fuels. Okay. So let's make some like these. So like this. So when there are many machines in the factory, so they need a fossil fuel like carbon. Carbon they need. Okay, so they need carbon and sulfur, nitrogen to start to do work. They need the fossil fuels. So what they after the work, the wastage come out. Now coming. So when the carbon dioxide is burned and it changes into the fossil fuel. So we add iodide. So we get carbon dioxide, and from sulfur we get sulfur dioxide, and there is 3 at here. We say like this. Sulfur 3 like this. Okay, and in nitrogen oxide. Okay, so when they come in the monsoon season, there are some clouds. So when they come in contact, the pure water is falling. But after the mixing of the sulfur oxide and carbon dioxide, nitrogen oxide, and what happened? They mix up and change into the yellow, and they falls on our earth like this. Like this. They are falling on the earth, and this is too harmful. And what we do? We dance in the rain, okay? And agriculture also gets harm through it, okay? Our crops, our wheat, maize, they get harm, and there is very loss of the farmers in the monsoon season when there are acid rains. So the most dangerous oxide here is acid rain, which is sulfuric. Sulfuric 3. Okay, it is too harmful. Okay, it is too harmful. Okay, and the government also banned that there is the after when there's the a big quantity the sulfuric acid rain is going on. So some pupils are doing business of it. Okay, they do trade with the sulfuric tree.